a residential electrical system, specifically at the main service panel, there are very specific requirements regarding the separation of neutral conductors and equipment grounding conductors. According to the National Electrical Code, specifically Section 250.24, A5, in a service panel, bonding jumpers must be connected as specified in Section 250.28. D. Section 250.28. D further elaborates, stating that in service equipment, the bonding jumper or jumpers must be connected to the equipment grounding bus at the point where the bus is connected to the grounded service conductor, which is the neutral. This effectively mandates a separation between the neutral bar, where neutral conductors terminate, and a grounding bus, where equipment grounding conductors terminate. The only intentional connection between these two separate buses should be the bonding jumper, which provides a path for fault current back to the source. The purpose of this separation is to ensure that under normal operating conditions, the return current flows exclusively through the neutral conductor and not through the equipment grounding conductors or the metallic enclosures of electrical equipment. This is crucial for safety and proper system operation. If the neutral and ground are improperly connected, it can create a situation where current flows through unintended paths, potentially energizing metallic parts of appliances or equipment, creating a shock hazard. The green ground screw, typically found in a service panel, serves a specific purpose. It's intended to bond the enclosure of the panel to the grounding bus. This ensures that the metal enclosure itself is at the same potential as the equipment grounding conductors, providing an additional layer of safety in case of a fault. However, the green ground screw is not intended to, and should not, connect the neutral bar directly to the grounding bus. Such a connection would bypass the intended separation and could lead to the aforementioned problems. When examining a main service panel, there are key indicators to look for to ensure compliance with the code. Firstly, the neutral bar and the grounding bus should be physically separate. They may be located in the same panel, but they should not be directly connected except through the designated bonding jumper. Secondly, the bonding jumper should be clearly visible and properly connected between the grounding bus and the point where the grounded service conductor, the neutral, enters the panel. Thirdly, all equipment grounding conductors, such as those coming from branch circuits, should terminate on the grounding bus. Fourthly, all neutral conductors should terminate on the neutral bar. If these conditions are not met, it indicates a potential code violation and a safety hazard. It is important to understand the difference between grounded conductors and equipment grounding conductors. Grounded conductors, or neutrals, carry the normal return current from electrical loads back to the source. Equipment grounding conductors, on the other hand, do not carry current under normal conditions. Their sole purpose is to provide a low impedance path for fault current to flow back to the source, allowing overcurrent protective devices, such as circuit breakers or fuses, to trip and to energize the circuit in the event of a fault. In older electrical systems, it was sometimes common practice to bond the neutral and ground at multiple points throughout the system. However, modern electrical codes strictly prohibit this practice, except at the service entrance or separately derived systems. Bonding the neutral and ground at multiple points can create circulating currents in the grounding system, leading to nuisance tripping of overcurrent protective devices, increased electromagnetic interference, and potential shock hazards. When upgrading or modifying an existing electrical system, it is crucial to ensure that the neutral and ground are properly separated and that the bonding jumper is correctly installed at the service entrance. This may involve rewiring portions of the system to comply with current code requirements. If you are unsure about any aspect of electrical wiring or code compliance, it is always best to consult with a qualified and licensed electrician. Attempting to perform electrical work without proper knowledge and experience can be dangerous and potentially life-threatening. There are several reasons why the separation of neutrals and grounds is so critical for electrical safety. One key reason is to prevent neutral current from flowing through the grounding system. Under normal conditions, all return current should flow through the neutral conductor back to the source. However, if the neutral and ground are bonded together at multiple points, some of the neutral current will inevitably flow through the grounding conductors as well, seeking the path of least resistance back to the source. This can energize metallic parts of appliances and equipment, creating a shock hazard for anyone who comes into contact with them. Another reason is to ensure proper operation of ground fault circuit interrupters, commonly known as GFCIs. GFCIs are designed to detect even small imbalances in current between hot and neutral conductors. If a ground fault occurs, meaning that current is leaking to ground, the GFCI will quickly trip, cutting off power to the circuit and preventing a potentially fatal shock. However, if the neutral and ground are improperly bonded, it can interfere with the operation of the GFCI, preventing it from detecting ground faults and rendering it ineffective. Furthermore, the separation of neutrals and grounds helps to minimize electromagnetic interference, or EMI. When current flows through a conductor, it creates an electromagnetic field around that conductor. If neutral current is flowing through the grounding system, it can create EMI that can interfere with sensitive electronic equipment such as computers, audio equipment, and medical devices. By keeping the neutral and ground separate, the amount of EMI generated by the electrical system can be significantly reduced. In addition to the code requirements for separating neutrals and grounds at the service entrance, there are also specific requirements for grounding electrode systems. A grounding electrode system is a network of interconnected grounding electrodes that are used to connect the electrical system to the earth. The purpose of the grounding electrode system is to provide a low impedance path for fault current to flow to ground, helping to stabilize the voltage of the electrical system and reduce the risk of electric shock. Common types of grounding electrodes include ground rods, ground plates, metal underground water pipes, and concrete encased electrodes, also known as UFA grounds. The National Electrical Code specifies the minimum requirements for grounding electrode systems, including the number, type, and size of grounding electrodes that must be installed. It also specifies the methods for connecting the grounding electrodes together into the electrical system. It is important to ensure that the grounding electrode system is properly installed and maintained to ensure its effectiveness. Regular inspections should be conducted to check for corrosion, damage, or loose connections. If any problems are found, they should be corrected immediately. When working with electrical systems, it is essential to always follow safe work practices. Firstly, always to energize the circuit before working on it. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. Secondly, always use appropriate personal protective equipment such as safety glasses, rubber gloves, and insulated tools. Thirdly, never work alone. Always have someone nearby who can assist you in case of an emergency. Fourthly, if you are not comfortable working on electrical systems, it is best to call a qualified and licensed electrician. They have the knowledge, experience, and equipment to perform the work safely and correctly. The code also addresses situations where there are multiple buildings on a property that are supplied by the same service. In these cases, it is important to understand the requirements for grounding and bonding in each building. Generally, the grounding electrode system should be installed at the main service entrance, and a grounding conductor should be run to each additional building. The grounding conductor should be connected to a grounding electrode system in each building. However, there are some exceptions to this rule, depending on the size and type of buildings involved. It is important to consult the National Electrical Code for specific requirements in these situations. When dealing with electrical panels, it is also important to be aware of the requirements for panel board identification. The National Electrical Code requires that each panel board be clearly and permanently marked with its voltage, current rating, and the number of phases. This information is important for ensuring that the panel board is properly sized for the load it is serving. Additionally, it is important to maintain a clear and accurate directory of the circuits in each panel board. The directory should identify the location and purpose of each circuit, making it easier to troubleshoot problems and perform maintenance. The National Electrical Code is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years to reflect the latest advances in technology and safety practices. It is essential for anyone working with electrical systems to have a thorough understanding of the National Electrical Code and to follow its requirements carefully. Failure to comply with the National Electrical Code can result in serious injury or death, as well as property damage. In summary, the separation of neutrals and grounds in a main service panel is a critical safety requirement. It helps to prevent shock hazards, ensure proper operation of GFCIs, minimize electromagnetic interference, and provide a safe and reliable electrical system. By understanding the code requirements and following safe work practices, you can help to ensure the safety of yourself and others. The key takeaways are: firstly, always separate the neutral and ground conductors in the main service panel, except for the bonding jumper. Secondly, ensure the bonding jumper connects the grounding bus to the grounded service conductor neutral. Thirdly, verify that the equipment grounding conductors terminate on the grounding bus and the neutral conductors terminate on the neutral bar. Fourthly, consult with a qualified electrician if you have any doubts or concerns about electrical wiring or code compliance. Fifthly, regularly inspect the electrical system for any signs of damage or deterioration and correct any problems immediately.